Hello everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research, and today is our 50th episode. So we are completing half century today. So I brings you one of my favorite problem in the assignment model, that is a typical maximization problem. Now in this problem we have two parts. So part 1 we are going to cover in this lecture, and the next part, second part, we are going to cover in the coming lecture. So let us quickly see what the question says. The question says that the captain of a cricket team has to allot 5 middle batting positions to 5 batsmen. The average runs scored by each batsman at these positions are as follows. So now in this matrix, P, Q, R, S, T are 5 batsmen, and 1, 2, 3, 4, 5 are the batting positions, and these are the average runs scored by a batsman at a particular position. So this matrix has been given and we need to find the assignment of batsmen's to positions which would give the maximum number of runs. So here in this problem our objective is to have the maximum number of runs. So it is a problem of maximization, and I have already written here the first matrix where we have 5 batsmen and 5 positions. So this is a 5 cross 5 matrix, and this means that we already have a square matrix, so we do not need to convert this into a square matrix. And now we need to understand that because our objective is maximization, that means this is a maximization matrix, and now we need to convert this maximization matrix into minimization form. So in order to do so, we will select the maximum value among these matrix. So as we can see here, the maximum value is 60. Okay, so the maximum value is 60. Now we are going to subtract each element from 60 and prepare a new minimization matrix. So let us solve here. So the maximum value is 60. 60 minus 40 is 20. So this is 20. Similarly, this will also be 20. 60 minus 35 is 25. 60 minus 25 is 35. 60 minus 50 is 10. 60 minus 42 is 18. 60 minus 30 is 30. 60 minus 16 is 44. 60 minus 25 is 35. 60 minus 27 is 33. 60 minus 50, 10. 60 minus 48, 12. 60 minus 40 is 20. 60 minus 60 is 0. 60 minus 50 is 10. Here 60 minus 20 is 40. 60 minus 19 is 41. 60 minus 20 again 40. 60 minus 18 is 42. 60 minus 25 is 35. 60 minus 58 is 2. 60 minus 60 is 0. 60 minus 59 is 1. 60 minus 55 is 5, and 60 minus 53 is 7. So here we have converted the maximization matrix into minimization form, because we always solve for minimization in assignment model. And now in this model we need to reduce this matrix in such a form that each row and each column has at least 1 0. And in order to do so, first we will do row reduction. That is, we will select the minimum value in a row. Suppose for row 1 the minimum value is 10, so we will subtract 10 from each element in this row, and subsequently we will do for other rows as well. And similarly, to obtain the 0, at least 1 0 in the column, we will do column reduction, and so on. So let us start here. For row 1 the minimum value here is 10, so this is 20 minus 10 is 10. Again 20 minus 10 is 10. 25 minus 10 is 15. 35 minus 10 is 25, and 10 minus 10 is 0. Here the minimum value is 18. So 18 minus 18 is 0, and 38 minus 18 is 12, and 44 minus 18 is 26, 35 minus 18 is 17. 33 minus 18 is 15. Here in this row the minimum value is 0. That means this row will remain as it is. So this will be 10, 12, 20, 0 and 10. Now moving on to this row, the minimum value here is 35. So we will subtract 35 from each element. 40 minus 35 is 5. 41 minus 35 is 6. 40 minus 35 is 5. 42 minus 35 is 7. 35 minus 35 is 0. Similarly, for the last row, we already have a 0 here, so this row will remain as it is. So this will be 2, 0, 1, 5 and 7. So after row reduction, we have 0 in each row, but we do not have 0 in each column. So we need to do column reduction. For that, we will select the minimum value in the column and subtract each element of that particular column by the minimum value. So for column 1 and 2, we can see that there are zeros present. So these two columns does not change. So they will remain as it is. 10, 0, 10, 5, 2. This is 10, 12, 12, 6 and 0. Now in column 3, we can see the minimum value here is 1. So 1 is subtracted from each element in this column. So 15 minus 1 is 14. This is 25. This is 19. This is 4 and this is 0. Now for column 4 and column 5, we can see that both are having zeros. So these two columns will also remain as it is. So this is 25, 17, 0, 7, 5, 0, 15, 10, 0 and 7. Now once we have reduced our matrix, now we need to assign we need to make assignment in this particular matrix. So we know that to make assignment, first we will try to assign row wise and then column wise assignment. So if there is a single 0 in a row, we are assigning it, and if there are more than one 0 in a row, we will skip that row and move on to the next row, and same can be done with column. So let us start here. In row 1, we can see that we have a single 0 here. So we will assign this 0, and once this 0 is assigned, no more assignment can be done in this row and in this column. So this 0 gets crossed out. Now moving on to row 2, we have another single 0 here. So we will assign this 0, and once this 0 is assigned, no more assignment can be done in this row and in this column. Now moving on to row 3, again we have a single 0 here. So we will assign this row, assign this 0, and once this is assigned, no more assignment can be done in this row and in this column. Now moving on to row 4, we do not have any unassignable 0 present here because this 0 has been crossed out. So we will skip this and move on to row 5. In row 5, we have more than one 0 here, so we will skip this, and now we will try to assign column wise. For column 1, we can see that one assignment has been there in column 1, and now moving on to column 2, we can see that there is a single 0 present. So we will assign this 0, and once this 0 is assigned, no more assignment can be done in this row and in this column. So this 0 is getting crossed out. Now moving on to column 3, we can see that in column 3 no more assignable 0 is present. So we will skip this, and now we can see that all the zeros are either assigned or crossed, and we have 4 number of assignments. Now we know that in a 5 cross 5 matrix, to have an optimal solution, we need to have 5 assignments, and here we only have 4 assignments. So we understand that our solution is not optimal. Now in order, what we will do is we will draw minimum number of lines that crossed all the zeros. Now in order to draw minimum number of lines that cross all the zeros, we need to follow certain step. So the first step is to tick the unassigned row. So among these, this is the unassigned row. So we have ticked the unassigned row, and if this row has a 0, tick the corresponding column. So this row is having a 0, so we will tick the corresponding column. And then if this column has an assignment, tick the corresponding row. So we can see that this column is having an assignment, so we will tick the corresponding row. And as no more zeros are here, no more further ticking is possible in this matrix. And now we need to draw lines through unticked rows and ticked columns. So we will draw lines through these unticked rows. So unticked rows and ticked columns. So there is only one ticked column. So now we can see that there are three types of cell. First is the cell where no lines are passing. So for this cell, we will select the value theta here. Theta is the minimum value in the cell where no lines are passing. So we can see that among these cells, the minimum value is coming as 4. So the value of theta is become 4. And now we need to prepare a new assignment matrix. And in order to prepare a new assignment matrix, we can see that there are three types of cell. First is where no lines are passing. Second is where a single line is passing through the cell. And the third is where two lines are passing through the cell. Okay, so first we will see the cell where no lines are passing. For this cell, the new Cij, that is the new cost coefficient, is equal to the old cost coefficient minus value theta. So this is 10. This will be 10 minus theta, that is 10 minus 4 is 6. So let us write here 10 minus 4 is 6. Similarly here 10 minus 4 is 6. This is 14 minus 4 is 10. Here 25 minus 4 is 21. And now 5 minus 4 is 1. 6 minus 4 is 2. 4 minus 4 is 0. And 7 minus 4 is 3. So we have calculated the values for the cell where no lines are passing. Now for those cells where single line is passing, the new Cij or the new cost coefficient will be equal to the previous cost coefficient or the cost coefficient in previous matrix. So these cost coefficient where single line is passing will remain as it is. So we will write this. This will remain as it is: 0, 0, 12, 25, 17, 10, 19, not 19, this is 12 I think, 10, 12, 19 and 0. Similarly here 2, 0, 0 and 5. This will also be 0. So we can see here that we have calculated values for the cell where single lines are passing. Now there are three cells where two lines are passing. For this cell, the new Cij will be equal to the older Cij plus the value of theta. That means if this is 15, 15 plus theta, that is 15 plus 4 equal to 19. So this will be 19. Similarly, this is 10, 10 plus 4 is 14. Here it is 7, 7 plus 4 is 11. So we have calculated the new assignment matrix here, and again we will try to make assignment in this matrix, and we will follow the same procedure. First we will try to assign row wise, then column wise. If there is a single 0 in a row, we will assign that 0, and if there are more than one 0 in a row, we will skip that row and move on to the next row. And same we will do about column. So let us start. Starting from row 1, we can see that in row 1 we have a single 0 here. So we will assign this 0, and once this 0 is assigned, no more assignment can be done in this row and in this column. So this 0 will get crossed out. Now moving on to row 2. In row 2 also we have a single 0. So we will assign this 0, and once this 0 is assigned, no more assignment can be done in this row and in this column. Now moving on to row 3, we again have a single 0 here. So we will assign this 0, and once this 0 is assigned, no more assignment can be done in this row and in this column. Now moving on to row 4, we can see that we have now a single assignable 0 present here. So we will assign this 0, and once this 0 is assigned, no more assignment can be done in this row and in this column. So this 0 will get crossed out. Now moving on to row 5, we can see that we have a single assignable 0 present in row 5. So we will assign this 0, and once this is assigned, no more assignment is possible in this row and in this column. So we can see that now we have total 5 number of assignments in a 5 cross 5 matrix. That means our this solution is optimal. So we can see the assignment made here is for P, it will play at position 5th, 5. Q will play at position 1st. R will play at position 4. S will play at position 3, and T will play at position 2. And here now we can see that this is the optimal assignment, that P will play at 5, Q at 1, R at 4, S at 3, and T at 2. Now in order to find the value of Z, that is the total maximum runs scored, we need to look at the maximization matrix. So this is the maximization matrix that is given in the problem. So here for cell P5, the value here is 50. So this value is 50. Similarly for Q1, we have the value as 42. For R4, we have the value as 60. For S3, we have the value as 20. And T2, for T2 we have the value as 60. So by adding up all this value, we can calculate the value of Z maximum here. So Z maximum will come as, this is 120, 140, 182. This will be 232 runs. Okay. So this is the maximum value of runs that can be scored by having this assignment to the batsman. So we have completed the first part here, and we have calculated the assignment and the value of Z, that is the maximum runs that can be scored. Now to solve the second part, we will continue it in our next lecture. If you like the lecture, please share the lecture. Have a nice day. Thank you.